Good morning, good afternoon, good evening, good day, whatever the day might be over there. The title of my presentation is Uncovering Hidden Patterns, the Importance of Statistical Analysis. I'm Professor Gafar Matami Oyeyemi, Department of Statistics, University of Ilorin. When we talk of complex data, we are referring to big data. And we're talking about when we have so many variables in hundreds, even in thousands, and the number of observations as well as many as possible. In fact, in most cases, the number of variables are more than the number of observations. When we talk of microarray data, in which we have so many variables that we are dealing with. So most often the researcher will find themselves in trying to look at the patterns or the hidden patterns that may be inherent in that complex data. So they will be looking for tools to uncover those hidden patterns, similarities, or trends that the data may have. And this is where the statistical tools, we call them most often multivariate statistical techniques, such as factor analysis, cluster analysis, discriminant analysis, among others, come into play. And this presentation will dwell on just two of them, and that is factor analysis and cluster analysis as a powerful tool, as powerful tools or techniques to uncover hidden patterns in real-life situation. Cluster analysis factor versus factor analysis. Most researchers, especially the non-statisticians, do confuse cluster analysis with factor analysis, whereas the two are not the same. We talk of factor analysis when we group or we collect data points or observations in a way that members or individuals in a particular group are very similar to one another, and they will be quite different from members in other groups. That is a clustering analysis, or what we call cluster analysis. Whereas factor analysis can be likened to a detective tool for researchers. It helps in simplifying complex data by grouping similar variables together. The variables that are related, highly correlated, will be grouped together. So factor analysis aims at uncovering hidden factors that are likely to influence our observed variables. So that is what we call factor analysis. So the diagram above on display is a pictorial form of factor analysis. Those yellow rectangular boxes are the items or the variables that we measured. So where the blue circles or the blue bars are the factors extracted from those. You can see that you see some instances, 2 or 3 items are grouped together to form a factor, or even more variables or items are grouped together to form a factor. So this is how factor analysis look like. Then we talk of clustering. The diagram on display gives us a pictorial form of a cluster analysis. We call it dendrogram. You see on the horizontal axis a list of countries, and these countries are being grouped in clusters, as you can see. So we are having, at the end of the day, we started with like 6 or 7 groups, and these groups, groups of countries are being collapsed together until we have either 2 or everything together to become one cluster. So the countries are being grouped together based on some characteristics measured on them. So as you can see, before the yellow group, let's say the red group, before it's grouped together were initially 2 groups. Before they were collapsed to one group. Then we have the green, the blue, and the other colors as we are seeing. So this is a typical example of a cluster analysis. Difference between the two. For any given complex data, cluster analysis will obtain possible clusters or groups of individuals or objects using some similarity functions. Whereas factor analysis will uncover underlying or hidden factors or patterns by grouping variables constituting the data into different constructs known as factors. Both techniques help the researchers in simplifying complex data in order to have a better understanding and interpretation of such complex data. There are similarities. They are both powerful techniques or tools for researchers seeking to uncover hidden patterns, themes, or structure within complex data. When we say complex data, we are talking about big data. They also simplify complex data and provide valuable insights, though they do not provide definitive answers, but they act as magnifying lens in revealing the patterns in the data that guide further analysis and investigation. So that is what they both do. So they are not definitive, they will not give definitive answer, so to speak, but they will help the researchers in magnifying the patterns that may be inherent in such complex data, so that it will help the researcher in doing further analysis or investigative analysis of that data. In statistics, most of these techniques, especially the complex data analysis like that, we need to have, we have two types of analysis, what we call exploratory and confirmatory analysis. So we have it in both cluster and factor analysis. So exploratory analysis is used when researchers are unsure of what they are looking for, but they just want to explore the data to see what it may likely bring forth. So the researcher may not know the number of clusters or factors, just as we did or we have in the pictorial display earlier. So data in the data, but we keep on exploring the data to arrive at an ideal number of groups or factors that will be meaningful or interpretable, or that will help in further analysis or investigation. Whereas in confirmatory analysis, the researcher employs sorts to have, when the researcher already has an hypothesis about the number of clusters or factors that the data may have, the study may have that is studying. And so now he wanted to test the theory by collecting information or by using such data. So we are having some, I'm giving some examples of cluster analysis. So an example is a situation in which a researcher is concerned about certain diseases, and such researcher collects information on environmental and genetic factors of individuals. So this will help in clustering such individuals or those individuals into groups, so that in order to make progress towards understanding that, okay, this group are likely to have this certain disease, this group are likely to have this kind of disease, and so on and so forth. And this will help in engaging how much individuals are at risk of a particular disease. Another example is moving streaming analysis that collect information on customers or viewers, maybe on Netflix or YouTube. So this information can help the analysts in grouping customers or viewers into groups or clusters based on their preference, whether they prefer action movie, fiction movie, or horror, as the case may be. So those are the two examples of cluster analysis. Moving to factor analysis. In a business survey that is aimed at studying what matters most to the employee, the business survey They're studying what matters most to their employees. So when you do that, there are going to be many variables that may impact employee experience. So these variables will be many. So factor analysis will help us in having narrowed down to potential to narrow down or reduce all these variables into a few manageable hidden variables, or what we call factors. So understanding these factors will help the management or in hiring process much easier. So it make sort easier for the management or the business owner. Another example is conducting customer satisfactory survey. We know that there is always going to be a lot of variables in relation to customer preference for a particular product, because they weigh these items, these variables, before they buy or purchase a particular product. So factor analysis can help us in grouping these attributes, or what we call variables. And this will enable the management to see the forest through the trees. That is, give them a better understanding of the customer preference, or what the customer actually looking for in their products. So those are the typical or two examples for factor analysis. So we look at some cluster analysis methods. We have nearest neighbor, we have furthest neighbor, group average, centroid, median, and word method of cluster analysis. And for the methods of factor analysis, we have principal components analysis method, we have common factors method, we have image factoring, least square method, and principal axis method. So therefore, thank you for listening. God bless you.